speaking about what short-wave infrared 1 to 2 micron area can do for defense applications. I'll first talk more widely what short-wave can do, of course, always having an Emberion angle in mind, and then at the end tell a bit more about Emberion offering in short-wave area. So about 2 areas covered in a quick presentation. I'm one of the founders of Emberion. We founded Emberion in 2016 and currently in charge of product management and marketing. And yeah, looking at the participation both in Zoom and probably also in YouTube, it's really great to have that many people on board. So looking forward to the questions most importantly. So as first, what can shortwave do in defense? I think the key message, there's one thing you want to take out, what can shortwave imaging do in defense? You have more information on the battlefield. You need to know more than the guy on the other side of the battlefield. You look at here as an example, infantry smoke grenade donated in a UK military base. So military stuff, no toys. Left-hand side, you see an image of visible light camera, and the right-hand side, you see an image with shortwave, in our case, of course, Emberion camera. So you basically see that you have a quite nice transparency of those infantry smoke grenades with shortwave. So basically, one area, there are 3 areas what shortwave can do on battlefield or in defense. But here I'm brutally speaking about battlefield because that's what we really what we end up to. So you want to have visibility in different conditions. I just showed the smoke grenades, a bit more material on that one. You could seeing through smoke is very good example. Smog, snowstorm, haze are good examples, and we also can improve the visibility through fog. In terms of drones, a very specific case are the laser weapons. Example of UK MOD's Dragonfire that they developed with the British primes, and is being deployed by the UK Defence Forces. But that's not the only one. You shoot a drone with a laser. You want to make sure you hit the drone and it gets destroyed. When you get the pile of smoke and dust, and you want to see through that dust smoke pile, and that's a shortwave camera can make a big difference. The other area beyond the visibility is to see what's on the battlefield. Very simple one. You want to see the nets. You want to see camouflage uniforms. Perhaps camouflage uniforms you can do also with a thermal camera. But when you start covering vehicles, other equipment, the thermal camera won't necessarily work there. So you want to make a difference to the camouflage nets to the background. I have here a couple of images taken with shortwave camera and a visible light camera of a guy in the bushes. I'll have that actually as a bigger one, but that tells the difference that you can see more information of the objects. When you take this one to next level, what you want to do, or what you can do, is basically making spectral fingerprint of the battlefield. Look at the objects, and there you can see what's ours, what's theirs, what's third party, to know what to shoot, what not to shoot. Third area, and I'm seeing quite a lot of traction there at the moment in the world of defense, is to see lasers. Think about a very clear use case. You're on the battlefield, you are designating with a laser a tank for a missile that has been launched, for example, from a jet, fighter jet, to hit the tank and destroy it. You want to be 100% sure you are pointing at the right spot at the tank, ideally the tower. At least that's what I know is the weak point, and the right tank. So you look with the shortwave camera at the shortwave laser image and make sure you are spotting at the right one. The other way around, you want to see and detect if you are being pointed with the laser designator or laser rangefinder. So you see where the laser beam comes from, and then you can assume something, you will be impacted quite soon with something. So you'd better turn your tower and impact and eliminate the source of the laser before they eliminate you. So these are the 3 areas where we see the defense in the world of defense, the short wave can do a difference. And I'll give a couple of more images as examples. Here we get back to the smoke grenades. Bottom left, you see the images, the same case, infantry smoke grenades you can run through, you use with your own troops. You see how well you see through them. Now, if I'm at the tank and I see a laser, I probably use my phosphor grenades or other smoke grenades to detect and to prevent the laser and the missile hitting me. Now, on the right-hand side, you actually see that 1550 lasers do penetrate these phosphor grenades. So, and you also see on the right-hand side that with a short wave, you don't necessarily have a full see-through phosphor smoke grenade used for example, tank self-protection. But you do have an advantage. You see more than you see with the bare eye or visible light camera. So you have a partial transparency through even phosphor grenades that you wouldn't use it for the infantry, but you wouldn't send your own troops through because it's pretty ugly stuff. We have, I'm not showing videos here, but we have a lot of videos on our YouTube channel, Emberion YouTube channel. So have a look. Usually have a bad experiences of showing videos on live streams, so decided to stick to the still images. But have a look at our YouTube channel. Then the next one I mentioned about seeing through the identifying camouflage or nets on the battlefield. Here you see example on left-hand side, the person is hard to see. On the right-hand side, nicely sticking out of the bushes. And third one, the lasers. Here again, you can have a laser rangefinder. You want to see the spot you are measuring to, or vice versa. You want to see on the right, top right and bottom right, of the 4 images, you see the laser rangefinder being very clearly visible and somebody pointing you at. It's a very low power, extremely low power 1550 nanometer laser rangefinder. So if you, for example, have a designator, they have a much stronger power, so they are fairly easy to spot from long distances when even this very low power laser rangefinder can be seen from a distance. So these are just examples what you can do with laser in terms of seeing lasers either side of the battlefield. Just seeing how we are doing in timing. Then perhaps quickly about Emberion at the end. So we do shortwave infrared sensors. We built them ourselves. We designed them ourselves and built cameras around them. So we designed it from starting from the readout IC. We deposit quantum dots on top of silicon in our Cambridge facility in UK. And then we built full camera with firmware around it. We do the electronics part, IC design part in Espoo and Finland, and then we do the nanomaterial deposition, which is the photo-absorbing nanomaterial with a deposition we do in Cambridge in UK. And of course, we work in defense. This topic about this presentation and this session, but we also active in the civilian side, in the machine vision side. And the product is a camera size of a faced 4 by 4 by 7 centimeters, weighing 150 grams, or if you take the core without any mechanics, it's 102 grams, and there is a bit more to come. So the key advantage is in the area of defense of our technology. One thing is the dynamic range. We go up to 120 dB. So if you have a very bright spot in your image and you want to see also where the bright spot comes from, the laser designator, high dynamic range is an advantage. So this 120 dB dynamic range in logarithmic mode is quite unique. It comes from our own measurement principle. We have high speed when you go into hyperspectral imaging. So when you start scanning for example, the battlefield, not only looking for single wavelengths, but you do a hyperspectral imaging of the battlefield. We have the speed that the hyperspectral cameras require. And there have been quite nice examples putting a hyperspectral camera into a drone And I think I'm seeing somebody from Norske here. So from Hyperspecs, I have seen a very nice video where they put the hyperspectral camera into drone and scan the forest environment with people in their gear during winter time. So you can nicely see what's there and gather much more information in the area of shortwave. And the third area, bottom right, is the spectral range. We cover spectral range up to 2000 nanometers, in future even higher, up to 2500. And there, the key value is to see the lasers as long as they are needed. Now, lasers are 1064, 1550, but in future, there might be a reason to go even higher in the range of 2000 nanometers for the lasers to be invisible to the most cameras and detectors, and also to penetrate smoke grenades, whatever are the elements in the air. And as a final slide, what do we do now and what do we do next? We offer today capability for laser detection, seeing things, seeing through the elements, smoke, fog, whatever mentioned, and then also identifying the objects on the battlefield, like the camouflage netting. Next year, we will have a camera version with SDI interface and SWAP optimized, meaning size, weight, and power optimized camera that will consume less power and is ideally for any battery operation or even flying one like drones. So the integration into drones becomes much easier when our camera is less power and weighs less. So it will be a very attractive opportunity for drones and even for dismounted soldier. We will have also later next year a sensor that is built according to requirements of hyperspectral imaging for push broom. So we have a monochromatic sensor that's built according to spec of push broom integrators and will provide very interesting performance up to 2000 nanometers and even higher. And we're currently shipping VGA cameras. Next year, we start shipping megapixel. Then beyond next year, there's one very interesting area, and I know we will be hearing more about mid-wave. We are also working on a quantum dot-based mid-wave camera. Still developing the technology. The objective is to have it not non-cryo-cooled, but basically working with thermoelectrical cooling. We do cool it down to -degrees, but no need to go to -200 degrees like the cameras that are being quite often used today, where there is liquid nitrogen running and cooling the camera. That's kind of in a nutshell what shortwave can do for defense and what Emberion offers for defense in shortwave. I guess my time is pretty much up.